Hi everyone. Well, thanks so much for joining our last meetup of the year in December 2020. Hopefully the next one is going to be not online, but an actual person. So today we have two speakers. So we have Aaron Job from Deloitte and Praveen Manchana from Aceik. So we're going to start with Aaron, and his presentation is about a Sitecore case study, choosing the correct lifestyle where registering dependencies. Sorry. Here you go, your turn.
Yep. I'm assuming everyone can see my screen. So today I'm just going to quickly talk about a case study, or basically an example of an issue we ran into in managed services, and what it turned out to be, and just a few thoughts about how it could have been avoided. And yeah. If people don't know me, my name's Aaron. I'm a specialist manager at Deloitte Digital. I've been building websites for about, professionally for about 13, 14 years, mainly in the .NET stack and using Sitecore. I go by the handle Gravy Power. You can see that my blog, my Twitter handle, and my GitHub account. This came from my tune. I'm an ex-WoW player, so his name was Gravy Power, and it just stuck. So yeah. So when I first joined the managed service team earlier this year, which seems like a lifetime ago, between the lockdowns, this was the first major incident I was involved in. So this is its story. Trump invaded a website. So one Friday morning, I received a call from a client with some interesting news. Trump had appeared on their website where he wasn't meant to be. There was an article that had featured him elsewhere on the website, but he was appearing somewhere where it was not appropriate for Trump to appear. So a number of things went through my mind when this first happened. It's like, had we been hacked? Had a content author accidentally chosen the wrong picture? Was there a caching issue? Like a number of things was going through my mind. So we had a closer look at the problem, and it seemed to only exist on one of the two CD servers. So we weren't really quite sure what was going on, but luckily enough, a publish fixed the issue. So the theory was maybe it's got something to do with the cache. So as everyone here knows, you publish, Sitecore dumps the HTML cache, and everything's regenerated. I'm lucky enough to work with some pretty talented people. One of them, who's pictured here, Harry, who works on my team, he's a pro at reading memory dumps. So we found that we took a memory dump of what was going on and how Harry analyzed it. And we found that the rendering model, the rendering model had already been initialized before the rendering was used. Like, we weren't really quite sure what this could mean. So the likely suspect from here has its roots in one of my favorite things in the world, DI, and one particular lifestyle, which people on the call or watching may be able to guess from the picture. I have another presentation on this. I gave it last year, early last year, I think, a Sitecore flavored of that. But you can jump over there and there's a recording of a non-Sitecore version of that here if you're interested in learning some more about DI. So it turned out that the problem was that the view rendering was registered as a singleton. Now I will get into why this was a bad thing in the next couple of slides, but just first, just want to talk about like when you are registering things in your DI container, like how there's this concept of lifestyles, and that instructs how to basically when to create new objects when you request things from the DI container, or when to reuse them. First one we have is the transient, then we have scoped, and then singleton. So transient, a new instance every time. So when you register a service as a transient, in your container, you're implying the life of any resolved object from that registration is short-lived. So each time you request that particular service or type, a new object is created and returned. Singleton, there can be only one. So basically singleton is not the same as a static thing, but a static variable, but a very similar concept. Like for the life of the application, there's only one, the same instance is returned every single time. The singleton pattern is one of the gang of four patterns of reusable design. If you're interested, you can go read that book. And then we have the scoped, and the order is, that's correct, but so basically this means a new instance per scope. So the container returns the same instance of an object each time it's needed within a specific scope. But what is a scope exactly? When you think about scope in terms of dependency inversion, think of it as reusing an instance of an object for some defined period. So you could be one instance per HTTP request, one instance per HTTP session, one instance per thread, or maybe even one instance per application. So when you think about it, singleton and scope lifestyles really are the same thing. A singleton lifestyle is basically a scope lifestyle. It's scoped to the lifetime of the application. So what has all this got to do with Trump appearing on the website? So I'll try to use the analogy of a chalkboard and a notebook to represent the view rendering and the HTML cache. The view rendering being the chalkboard and a notebook being the HTML cache. It's like having two or more people keeping a list of properties on chalkboard. The chalkboard, as I said, representing the rendering, recording the details, things that are generated, and it's responsible for generating HTML. So hero banners, rich text, panels, etc. And the people who are accessing the website are the people who access the website write these things down on the chalkboard. So here we have person A, they come in, they have the title, and that's blue. The text of that is join the generic site today, and there's a picture of glasses. So once they've collected these properties, they start to draw them on the chalkboard. Start to draw them into the notebook, which is represented by the cache. However, the issue is when person B comes in and starts to write things on the blackboard as well. So they've got a color black. The text should be, everyone says this slide is the best, and there's a picture of dancing. Person B starts drawing their hero or their site for the Trump news article in the notebook and finishes it correctly. However, when person A comes back and looks up again to put their finishing touches on their hero banner, they're writing into the notebook, which is the cache. Instead of seeing a picture of glasses, they actually see the picture of Trump dancing. So they instead draw Trump dancing into the notebook. So then when person C comes along, they'll see, and they request the same page as what person A was looking at, they'll see the incorrect, the request will be resolved from the cache, and the incorrect HTML will be returned. Whoop. So basically, as we see here, person B, they see the correct thing. However, person A and C aren't seeing the correct rendering. They're seeing some seemingly random mashing up of these two things. This is way quicker than I thought it was going to be. So what's the moral of the story? Well, first off is don't use simultanes. Be careful with scoped, and your default position should be transient. Now, this isn't strictly true. Singletons, you can use them. Things like configuration for your application, that's something that doesn't change for the entire life. If you're wanting to inject, you're using some Sitecore settings, for example, and you've got, rather than accessing them through the static method, through the static object, sorry, the configuration class, and you've got some sort of factory pattern to access this, you could register that factory as a singleton, or the result of that factory as a singleton, because you know that those things aren't going to change. It's going to be the same every single time. Same for logging. Generally, a lot of the time in Sitecore, it's changed in recent years, but you just used to access the logging class directly with the static accessor. So the same deal is with here. Like, you've got something that's only one thing exists, so you can access it. Beyond programming sites, if you're doing something that interacts with something in the physical world, quite often that's where a singleton is useful as well. Like, you're mapping to something, you're mapping to something like a drone in real life, and you only have one particular, it's only one of those things to control. So making it a singleton makes sense. And as always, if you're directed by the library that you happen to be using, which is a bit of a bonus one. Sometimes you don't have to think about it. When you're reading through the library's documentation, it says you should register this as a singleton. I know one of the libraries I've been using for a personal project, it's called Martin, which is a database and event sourcing framework. It explicitly calls out that one of its types should be registered as a singleton against your DI container. I'm sure there's a reason for that, but I'm not quite sure exactly why they've said that. Scope lifestyles. So these are usually for when you want to keep a mutated state for some period of time. So like a database connection, you might want to use the same database connection for a particular unit of work. HTTP requests, for example, when the request starts, you make a connection to the database and do whatever thing you need to do. And then at the end of that request, you can close and dispose of that database connection. And the other two options I basically just went through. So when you have a mutable operation for some scope, think of it like some sort of bag for the request, where you want to pour a whole lot of things in there as the request is running and make a decision how to store something into the database or something along those lines. Or if you explicitly need to control how an object is disposed of, is when you would want to use scoped lifestyle. And once again, if you're directed by the library you're using, it's quite handy to sometimes your library, it's designed to work in a particular scope. Once again, that third-party library, the database Martin library, there's another part of that needs to be registered as scoped in the DI container, and that's so it can manage its caching lifestyle. And that was only 15 minutes. Is there any? So my apologies. I was hoping to be more, but work got in the way. Was there any questions about that, or would you like me to go back through the? Let me go back actually. So basically what was happening, I'll go into a little bit more detail about the scenario if this makes a bit more sense. So what seemed as some random event, we would get contacted by the client, and they're like some random things are appearing on the website, and it was baffling to what was going on. We deployed like viewers to see inside the cache. We checked to see if there was any issues with between the two CD servers, because the two CD servers were one server would show the correct thing and the other server would show the incorrect thing. So we thought maybe there was a problem with one of the CD servers, because the environment this was deployed into, the servers are like, they're pets, unfortunately. They're not like, we don't have like immutable infrastructure for this particular client. So that was confusing. Clearing the cache, or publishing or clearing the cache seemed to fix the issue. But then it would come back again and again and again, day after day after day. And it wasn't until, like I said before, like Harry came along and read through the memory dumps, and we sort of got some glimmer into, well, hang on a second, why is the model already populated with something? Like, how is that possible? It should be new and fresh each time. And that sort of then pointed us to look at, okay, well, maybe there's something wrong with the registrations, which I have to admit I'm a little bit embarrassed to say, but I didn't think about looking at the registrations. Quite often, once you set up the composition route, it's sort of like almost set and forget unless you need to edit it. And nothing appeared in testing or acceptance testing by our team or by the client, because there was only one or two users on the site at any one time. So it was really unlikely that two requests would come through at the same time that would be happening to use the same view rendering. Yeah, it was an absolute doozy. So I would definitely put that on your list of things to when you're debugging issues like this, when you've ruled out, no, it's not the cache, no, it's not the server, everything's fine. Check that the DI container is configured properly, because I don't know, I might be might be different, but like it just didn't occur to me. Yeah. Sorry about the shortness, but was there any questions or anyone want to share any other similar experiences that they've had, and something they never thought of was the cause, or they've got a story to tell about someone using a singleton in the code they support? Nope. Okay, in that case, thanks for listening to me ramble on for 20 minutes. You can go have a look at my blog if you like. I don't have a blog post up about this as yet, but one will be coming. Yeah, thanks.
Thank you so much, Aaron. That was really informative. I appreciate your time today. Any final questions, everyone? Okay, well, let's take a 5-minute break before Praveen starts, and see you guys at 6:35. I hope you guys heard that.
Okay, thanks a lot. See you then.
You're mute.
There you go. Hope you guys can hear me.
Yep, we can hear you, and we can see the slides as well.
All right. Yes, like some of you who don't know me, I'm Praveen. I'm a solution architect at Aceik. So I've been working with Microsoft technologies for about 14 years now, and Sitecore about like four and a half years, and I've done like 3 to 3.5 years of Sitecore Commerce. And I've got Gary from AWS.
Hello everyone, I'm Gary Singh. I'm a specialist solutions architect focused on Microsoft technologies on AWS, and got overall 14 years of experience in IT, done a fair bit of Microsoft technologies in the past, and AWS about a year and a half now.
So so what? Right. So today's topic is running Sitecore on AWS EKS. Like as most of you probably know already, that Sitecore with the release of version 10, they've started official support for container workloads in production. And like, I mean, a lot of people have been using containers for local development, and some of them also have been using in production. Like even before Sitecore officially started supporting container workloads. But with version 10 coming out, they've officially sort of started supporting container workloads. And probably in a few releases, they might actually even discontinue support for Azure App Services. So yeah, that's why we're talking about Kubernetes and Sitecore, and one of these flavors is AWS. So yeah, just a quick summary of what Kubernetes is. Some of you might have already done some reading up on Kubernetes. It was new to me like a few months ago, so I had to sort of read up on what Kubernetes is all about. So Kubernetes is a managed service. It is offered as managed service by a lot of the cloud providers these days, like AWS, Microsoft, or Google. These major cloud providers actually offer Kubernetes as a platform as a service. So what does Kubernetes consist of? It's got this API which is responsible for receiving all the commands, Kubernetes commands, that then gets passed on to the control plane, which actually then schedules it. Then it takes the configuration files and then performs a deployment into a particular node. So it uses etcd, which is actually a database for Kubernetes. So it's a key value store basically. So it actually stores all the secrets, or all the YAML files or the configuration files for your deployments. They're all stored in etcd. And then you have scheduler, which is actually responsible for taking those configuration files and then performing the deployment onto a particular node. So node is actually the thing that actually runs your applications inside of a pod. And then you have kubelet, which is actually an agent that runs on the node, which then talks to the actual control plane, to perform all the jobs. Kubeproxy, that's actually responsible for all the traffic management. That's how pods talk within the Kubernetes environment. So, for example, you have CD and you have XConnect collection. So CD and XConnect collection, they talk to each other through the kproxy, Kubernetes proxy. Then we have container runtime. Some of you might have known, Kubernetes 1.20 got released, and they're discontinuing support for Docker as a container runtime. So, for local development, most of us use Docker Desktop or Docker Enterprise. So that's actually a container orchestration software. So there's multiple different runtimes that are available. Like, one of them is Docker, then you have Containerd, and there's one more, I can't remember on top of my head, but Containerd is actually going to be the default for Kubernetes from 1.20 onwards. How does it affect us? Probably not, unless you're actually running your Kubernetes cluster yourself on your self-hosted like hardware. It doesn't affect us. Like, why do we want to talk about Kubernetes, and why do we want to even move to Kubernetes, right? So some of these auto scaling and healing capabilities within Kubernetes. And the next major thing is actually Sitecore is going to be deprecating support for app services in the coming releases. And Kubernetes is actually offered as platform as a service. So it's similar to what, running an application in Azure App Service, but obviously it's a different way of running an app. Instead of deploying your, application files into a web app, you'd be deploying an image into Kubernetes. The other important thing is securing your downstream communications. If you have your app, which needs to talk to your downstream systems, for example, like a CRM or some other downstream systems, you can actually protect that using a virtual network, because all the Kubernetes environments get provisioned inside of a virtual network. So you're actually reducing your surface of attack. And there's a really good video on YouTube. I would totally recommend watching it. That is our very own Rob Earlham. He's presented in one of those meetups on Kubernetes and the benefits of Kubernetes and why you'd want to move to Kubernetes. And we have Gary from AWS. He's going to sort of run us through what AWS has to offer for container workloads these days. I'll pass it on to Gary, and then we'll come back and then dig a bit more, and there's a demo as well.
Thanks, Praveen. Hello, everyone. All right, so let's quickly talk about our container service, that is EKS, and it stands for Elastic Kubernetes Service, which is nothing but the managed Kubernetes service, managed service for Kubernetes on AWS. Now, broadly, there is, landscape, the container landscape at AWS looks like what you see right now on the slide. That is, we've got two different orchestration engines. So ECS, which is Elastic Container Service, which is a fully managed container orchestration platform that is natively developed by AWS. It helps you, it is highly scalable, and it can has multi-tenant service that you can spin up on a large number of cluster service and tasks underneath the ECS. The other one is, of course, EKS, which is, again, a managed services built on Kubernetes orchestration engine, which gives you the flexibility to run and scale Kubernetes application into the AWS cloud or on-prem, and I'll talk about on-prem a little later. So essentially, if you have done investment on Kubernetes, and if you're running Kubernetes on-prem, it is fairly easy for you to move your Kubernetes application over to EKS without much of refactoring of your code, right? Then with both the options, we have, we give you an option for launch type. So what it means is you can either have the ECS or EKS launched on EC2. And for the folks who don't know what EC2 is, it's our Elastic Compute Service, which is nothing but a virtual machine running on AWS, right? The other option is Fargate. Now, with ECS, you get full control on your, so to say, virtual machine or the EC2 instance. You can, do the auto scaling based on what your thresholds are. You can log into the EC2 host. You can see what's happening there. Kill the pods. do a lot of, you essentially get a lot of control on your node, Kubernetes nodes running on EC2, compared to Fargate, which is more of a serverless orchestration engine, so to say. Think of it as, you don't have to worry about, running or managing the compute that you need for running Kubernetes nodes or pods. You don't have to worry about the underlying network security and so on and so forth, or patching of those, nodes and whatnot. All of that is again taken care by Fargate. You don't have to worry about the capacity essentially. Based on the certain triggers and tasks and the pods that you run on Kubernetes, Fargate will provision the underlying compute memory resources for your task that you want to run on EKS. Any questions so far? I'll move on. Sorry. Was there a question?
No, all good. Sorry.
Great. Right, so let's go a little bit more about EKS and what it is. So EKS runs upstream Kubernetes and is a certified Kubernetes conformant to get the experience that you would probably get with a production sort of Kubernetes deployment. You can easily migrate and any standard Kubernetes application, like I said, you might be running on-prem to EKS without much of code changes or refactoring your applications. Essentially, what you're running on-prem is what we are running in EKS, but it's more of an upstream Kubernetes where we actively sort of do the bug fixes for Kubernetes open source community version. It is highly available, built for production workload. We have many large customers who are running their Kubernetes workload on EKS. And if I recall, I think there was a study in 2017 or 2018, if I'm not wrong, and the study says 63% of the Kubernetes that are running globally were running on AWS. So just to sort of give you an understanding, how much of experience we have running Kubernetes on AWS. With regards to highly available, the way it works is, we deploy that Kubernetes or EKS across different availability zones. Now, for the ones who do not know what an availability zone, it's again it's more of it goes back to how the AWS infrastructure is designed. We unlike other cloud provider where you have regions and you have highly available platform setups across region. We have one region, and within that region we have multiple AZs. So usually every region will have a minimum of 2 AZs, but these days it's mostly 3 AZs across every region. And one AZ, it consists of multiple data centers. So there will be clusters of data centers that are interconnected with a very low latency. It's single-digit millisecond latency that we have between AZs. So if you are looking to build a highly available and low latency platform, and could be your SQL or whatnot, AZ comes into picture and really make you do stuff that you would otherwise do on-prem in a single data center. So that's where the highly available, 99.94% SLA comes into picture for EKS. The last bit is this being developed by us on top of Kubernetes orchestration engine. We have tightly integrated this with other AWS components such as VPC, which is virtual private cloud, and nothing but a isolated network, and within that isolated network you run your workloads. We have load balancers, we have IAM, which is identity and access management on AWS. We have operational side of things such as CloudWatch and CloudTrail. All of those services are tightly integrated with EKS, so you can take advantage of the ecosystem as a whole. And I know some of you might not be aware of the terminologies that I'm using, and try and elaborate on that. But yeah, it's pretty depth. So I would rather just give you a bit of brief on those things. So what does EKS do for you over running Kubernetes on EC2, right? Like I mentioned earlier, you can, of course, if you are pretty, if you've got a lot of experience running Kubernetes orchestration engine on-prem, you can move that across over to the EC2 instance, and start to manage your Kubernetes cluster and the orchestration engine as such, right? You can very well do that. That's more of lift and shift. What you can otherwise do is go on to EKS, which is the managed services that I talked about. And the benefit you get is, we deploy the Kubernetes control plane for you, including the cluster configuration database, that is etcd, in a highly available configuration across 3 AZs. So I did talk about what highly available means when it comes to EKS and what the AZ is. So if you are doing a Kubernetes cluster or the Kubernetes deployment on AWS yourself on EC2, you may have to spin up EC2 in one AZ and the second AZ and the third AZ, make them talk to each other, make sure that everything is highly available. Whereas if you go to EKS, it's out of the box. You get that, three AZ deployment for Kubernetes. The other good thing is, we manage the control plane for you via the automations and API. So with every managed services that we build in AWS, we build automation around it to manage it. There's very few instances when somebody would be going in and managing it manually. A lot of that management is taken care by the systems management service that we have in AWS. So EKS leverages that, and we manage this control plane for you on your behalf, which also includes upgrading it, patching the cluster, Kubernetes service, and so forth. In addition, we provide a network plugin, which is essentially a requirement to integrate your pod networking natively with VPC. Now, this is really critical. What happens is Kubernetes kind of designs its own networking within its cluster and between nodes and the pods, so they can talk to each other, like kube proxy is what Praveen talked about. What we do is what we have done in EKS is we have built that network plugin that sits on top of the nodes that runs the pod, and that plugin kind of integrates with the VPC, that is our networking layer, and make sure that the communication between the nodes, the control plane, and the pods are happening. So you can pretty much control all of that through the EKS API that we have available. And finally, we have integration with AWS API. So like I said, you can do a lot of management work or a lot of deployment of Kubernetes or pods through the APIs that we have developed for EKS, and that kind of interacts with the kubectl or the Kubernetes command line interface to ensure those pods deployment, node deployment is happening. Additionally, it also integrates with our identity and access management system, which helps you with the user access federation. So like I mentioned earlier, it does give you a really tight integration with all the other AWS services. So moving on, I'm just going to build a slide here. What it does not do out of the box, right? So we just talked about all the things and the fancy bells and whistles you have with EKS, but there are, of course, certain things that EKS does not provide, and you will end up doing it yourself. The first one is clustering the pod auto scaling. Now, it sounds like a lot of tasks, but it's not. It's pretty straightforward. All you do is you create a launch template in AWS, attach it to an auto scaling group, and then to your cluster, which takes care of auto scaling. So what essentially it means is similar to Azure, where you have the threshold defined. If the compute reaches like 80% or memory reaches 80%, you can have auto scaling kick in another node, and then you can the EKS would start deploying the pods onto the new node. So that's something that you will have to build on your own. In Fargate, you may not need that because Fargate looks after all of that. Again, Fargate would still require auto scaling, but Fargate would do the ECS deployment by itself in the sense that, so let me put it this way. With EKS on EC2, you would still define what the EC2 instance look like. So you probably want to have 2 CPU, 4 gigs of RAM, and you want a 2016 Windows Server, whatnot, right? So you would have control on the the instance that you deploy, you will have access to the instance. Whereas in Fargate, you don't have to define any of that. You just have to tell Fargate, you know what, go and deploy this pod and this node, and Fargate is going to take care of that for you. But with regards to auto scaling, that's something you got to define manually in Fargate as well. It's not there so far in terms of automating that. The other thing that we would do, you would have to deploy is the metrics with regards to storage and aggregation and alerting. So anything to do with logs, the metrics or the alerting, that doesn't come out of the box. And Praveen is going to show you a demo on that, how he built a log sort of data collection using CloudWatch Insight, Container Insight, and how that kind of all comes together. The third thing is the network and the security group policy. So it's really important that what we deploy on Kubernetes, we secure it, and we do have some certain policies that we deploy that we use at a VPC layer, which is our networking layer, to have right access control at a network level. That's something you will have to deploy manually. Not to mention the ingress controller. I think in our demo we have Nginx as ingress control. That's something you'll deploy yourself. And finally, the pod security policies or the OPA gatekeepers. These are, again, this is similar to what you have in any Kubernetes orchestration. Even if you're running on-prem, you got to have the right governance in place. You got to have the right admission control for the pods and nodes to make sure that no one is misusing it. That's what you will have to do on EKS yourself. Now, the good thing is, some of these bits and pieces can be automated using what we call as CloudFormation, which is, more of an infrastructure as a code. We do have some quick starts available to sort of, run EKS and have the cluster up and running and ready. But with Sitecore, I think it's pretty prescriptive with regards to how the deployment happens, and we have done that in a matter of like an hour or so, even less than that, Praveen, if I'm not wrong. So yeah, it's pretty straightforward. All right, moving on to the next one. So login and auditing, the control plane. Now, it's what we say in AWS is security is day one job for us, right? Or day zero job for us, not day one. So it's really important that you have audit trail of what's happening in the environment, who did what and when, and you've got a record of all of that somewhere so that you can always go back and have a look at that if anything goes wrong. So it's important that we have logging and auditing for the control plane. And in case of EKS, we have featured to stream the logs from control plane, including the audit trail to what we call as CloudWatch log service. So that's another service we have which aggregates all the logs and gives you metrics and alerts around that. This is enabled by default, this is not enabled by default, and you should turn it on and sort of regularly see it. In the demo, Praveen is going to show you how he's used the CloudWatch Container Insight with another open source technology to get all the metrics, additional metrics from EKS, and how that can be used from an operation perspective. Again, comes to login, it's part of that audit trail, a part of the security that we talked about. It's important that we do or collect all the login with regards to performance and whatnot. So on the left, if you see a common pattern that we see is to use a open source tool like FluentD, which is nothing but a data collector, which lets you unify your data for better consumption, for visualization. So what you see here is, you can use that FluentD along with the Elasticsearch, and then you can utilize and visualize your data from an operation perspective using Kibana, of course. And what it's trying to tell you on the slide is, you can, of course, use and manage all of that yourself. So you can run Kibana and Elasticsearch in your own nodes and pods, or wherever you like, or you can go with Amazon Elasticsearch, which is again a managed service, which also includes Kibana in there for you to sort of visualize and query those logs that gets generated out of EKS. The other way is to go with the native logging service that we have, which is Amazon CloudWatch, where you can use CloudWatch Container Insight to sort of send logs to CloudWatch logs, and then query it using another open source. I mean, you can of course look at the log as it is in CloudWatch, or you can use the container monitoring tool like Prometheus, which is again a open source tool, and Praveen is going to show a demo on that to sort of collect all the logs and the additional metrics that CloudWatch log will not collect. So you can view all of them in one sort of dashboard, and to sort of get a better picture of what's going on in the environment. That's with regards to logging and auditing. Guys, feel free to ask me questions if you have any. I'm more than happy to answer them as we go. I really want to talk about this slide. I mean, there's not much of content available for us to present to our customers and folks out there, but this is a new launch, I think, that just happened last week, and it talks about EKS Anywhere. Now, we see more and more customer wants to go hybrid. They want to have cloud and they want to have some work on-prem and whatnot. So we are being ahead in the game there, where we are giving you an option to deploy EKS on your on-prem, on your virtual machine, on your bare metal devices, right? On what we call as snow devices that we have that you can run EC2 instance on-prem. So essentially, it's a hybrid scenario, a hybrid use case where you want to leverage EKS, but you want to keep it close to your on-prem environment for whatever reason. So say, for example, if you're a customer who deals with mining sites and whatnot, and your workload is somewhere in the remote site, you want to deploy EKS onto that, certainly you can do that using EKS Anywhere. So what you get is the consistency that we have built around EKS, the investment and the research that we have done over the years, and we give it to you as sort of EKS distro that you can deploy on-prem, and you can manage all of that through one single console on AWS console using EKS management console that we have. So this is the power of what EKS can do for you. Not just run it on AWS, you can take it on-prem and run that anywhere you like. With that, there are additional services that we launched, which is add-ons and distros. So all of them come together and form part of the Anywhere, EKS Anywhere that we have just launched. There is very limited information available on this now. It's just been announced last week. If you guys have any questions, I can probably go back to research internally and come back to you on this.
I have a quick question on that, if that's all right.
Yeah, sure.
Can you have it so the workload running on the on-prem EKS is ring-gated to the on-prem infrastructure only, or is it got to be shared between infrastructure that's running on the cloud and infrastructure that's running on-prem? I'm just thinking data sovereignty problems this would be good for.
Absolutely. So what will happen is you have one EKS console, which is on the AWS console, right? And you manage your entire EKS environment from there. But you can have a cluster that is running on-prem on your bare metal or whatever it is, virtual machine, that can then be managed through the EKS console we have. So you have a holistic view of your entire EKS environment, no matter where it's just on AWS or on-prem on a virtual machine.
Yep. So it's not like if, just say, a node or a pod fails on the on-prem EKS implementation, it won't fail across. Can you set it so it won't fail across to something that's running in the cloud?
I'm not very sure. Like I said, it's just been launched last week. Cool. But I think the concern that you have, I'm sure many of our customers would have that. So haven't seen the nitty-gritties of it, but I'm sure there is a way for it to fail back on-prem. If not, I can tell you that we would have it very soon. I've seen services, we usually develop services and we launch it as a minimal viable product, right? And then we start taking feedback from customers. So all the services that you see today in AWS, almost all of them have been built based on the feedback we have received from our customers. So what we say is 90 to 95% of the features that we see on the services are from customer feedback. So we really take it very seriously. And if it's not available, I'm sure there'll be customer who would come back and say, guys, we need it. And we set those priority for those features, which are requested by a lot of customers. So if it's not there, I'm sure it'll come in at some point. It's a valid use case. Does that answer your question? I mean, not.
Yeah, no, I was more interested because I could see it'd be quite handy for those particular scenarios, especially like a payment gateway or something for a government agency or something along those lines, where like it has to be strictly controlled where that data is being stored.
I know for sure that there would be some sort of connectivity requirement between the EKS management plane, so to say, and the EKS that's cluster that's running on-prem. We would need to have some sort of connectivity. It does link with the region that you're running EKS on, but can it stay disconnected, and how long can it stay disconnected is something that I have to figure out. To me, it looks something like Outpost. I don't know if you guys know Outpost. That's like running a AWS rack on-prem. I think we have just launched the rack, so we have 1U and 2U racks now that you can you get from AWS. That's managed by us, and you can just plug it to your on-prem data center, and you have a same consistent experience of AWS services running on-prem. And that Outpost links up to your region where you're running that your account. So there is some sort of connectivity requirement, but it can. I think it should work in an offline mode as well. Again, I'll have to check on that. If you can leave your details with Praveen, I can do a bit of digging on this and come back to you.
Yeah, no, that's fine. I was more interested than anything else.
Sounds good. All right. So moving on, this is the last slide. Just want to talk about the different purchase options we have. So, it's not that you have EKS and you're stuck with one sort of, you've got to buy that EC2, you've got to keep it running all the time, you've got to pay for it no matter what. We do have different options for you to, consume the EC2 instances. If you are not doing Fargate, if you're doing EC2, then we have the traditional purchasing options for you. By the way, EKS kind of comes free, so there's no cost for that. The only cost you pay is for the resources that you consume. So on the left, as the name says, is on demand, right? You can, if you have a spiky workload and you don't know how much of capacity you need, you can start with bare minimum, and you can do on demand. So say if there is a spike and you need a additional node for next 2 hours, you can very well do that with on demand, and you pay for what you use. The second option is reserve instance, and that's for the customer who know that we need to run a bare minimum of 4 EC2 nodes, Windows nodes for Sitecore, say, and the maximum we go is 12. But the 4 is minimum, and I don't want to overpay for that. So let me just go and buy that under what we call as reserve instance. So you sort of commit to us upfront for 1 year or 3 year, and you save a lot of cost there to buy EC2 compute. The third option is similar to reserve instance, but it comes with more flexibility. That was launched, I think, last year, where you still commit to us certain numbers with regards to compute, but you have flexibility between the compute that you want. Unlike reserve instance, where you cannot move from one group of instances. So I don't know if you guys know, but we have instances like T3s, T2, M5, C5s. So you cannot move between the family of instances when you buy a reserve instance. Whereas with saving plan, you can move between anywhere you like. So it gives you more flexibility and more saving when you commit to 1 or 3 years or more. The last option is spot instance. So we do have spare capacity every now and then, and we don't want to leave it like that. So we give it back to the customer at a very but at a high discounted price, up to 70 to 80, 90%. The way it works is, you guys would bid for the EC2 instance for the compute, and if your bidding is the highest, you get that instance. I would not recommend that for workloads that are consistent. It's more for workloads that are stateless, maybe bad job and stuff like that, where you want to save money. You can especially go to spot instances. But if you have like, spikes coming in, I've seen customers doing really interesting stuff with Spot. They have built a automation around bidding and whatnot, and at the end they save money out of it. So it's a really great another tool in the toolbox for you to save money when you're running EC2 for your EKS. Well, that's about it from my end. I'll hand over to Praveen unless you have any questions for me. I'll take that as no. Thanks, Praveen. Thanks, everyone.
Thank you, Gary. That was really useful. I'm pretty sure other people will find it useful as well. Yeah, so digging into the actual demo. So this is a demo architecture that I've sort of put together. So what I've done is when you download the default Sitecore container package, all of them just go into just one pool, one pool, and all the pods sit in just one single node group, right? So what I've done is I've segregated them. This can again, based on your usage, you can actually segregate even further, move all the processing stuff into a separate node group, content management and identity server into another node group, and SQL Server and Redis and Solar, and obviously you're not going to run them in pods for your production workloads, you'd be using proper SQL Server. Content delivery, the delivery side, content delivery, it's kind of collection and ref data. These are the roles that affect the front end traffic. So segregated them into a separate node group, and then you have the default worker group, which is actually Linux nodes that is required for the control plane, where it actually deploys all the out of the box Kubernetes pods, kube proxy and all of these sort of stuff, live in the Linux nodes, right? So now another a sample architecture, this can be a real world an architecture where you'd have your SQL on AWS RDS and your Redis using AWS Elastic Cache for Redis. Then you do the auto scaling for your delivery node group, and have a management node group where all your backend stuff sitting there. So if for example, you have a processing job that's taking a lot of CPU, if you put that in a separate node group, it doesn't affect your front end traffic, right? So if a rogue pod or something that happens to be on the management side, it doesn't affect your live traffic.
The only thing I like to say is Amazon RDS here. So for the folks who don't know, that's again a managed services for relational database that we run on AWS. So RDS have options for running your SQL Server, Oracle database, MySQL, and Postgres. So again, a managed service like EKS, where we manage the database, the availability, the patching, and so forth.
And the other good thing about this is RDS and Redis, they're actually provisioned inside of the VPC, so they're actually protected. You don't have to go in and put whitelisting, IP whitelisting to protect your SQL instance. For example, Azure SQL, you deploy it into a region, it's open within that region. If you want to protect it, you can disconnect it from the rest of the world, but then you can have to put in IP whitelisting and stuff like that. But with RDS, it's actually provisioned inside of the VPC, so you have full control over the networking and all of that sort of stuff, right? The actual demo. All right, so let's dig into it. So I want to quickly show where things are provisioned in AWS. So what I've done is I've actually provisioned this before, and I have all my source code that I've used. It's all available on GitHub. I'll share one of the slides actually has links to my GitHub, and you can download it from there. It's got a README file with detailed instructions on how to go about getting this demo architecture spun up in AWS EKS. So first thing is the cluster. So you create a cluster with your node groups. So what I've done here is basically added labels to my node groups, and I've defined what type of instance that I want and what's my desired capacity. So how many by default, like how many nodes in that node group you would have. And then you can define like the minimum and maximum sizes. Like, if you define your auto scaling and all of that, then it's the maximum of 4 instances that are that for that node group, basically. And that's your disk size, like how much disk space that you want allocated for that particular node group. So yeah, what we have here is the default management one, which is like Linux nodes. And then we have data, which is where I've deployed SQL, Redis, and Solar. Then I have management node, which is where I've deployed content management, and then identity server. Then I've done processing and all the processing stuff into a separate node group. And then delivery server, like content delivery, Xconnect collection, and ref data. They're actually deployed into delivery. And after this, I've also made some changes into the out of the box. So these files under the Kubernetes folder, these are out of the box Sitecore YAML files. I've downloaded them, but I've added some customizations to it. So what I've done is I've targeted the node selectors to target a particular group. So, CM is going into Sitecore delivery. Oh, sorry, CD. Yeah, CM is going into Sitecore management. And if you look at one of the processing ones, it goes into Sitecore processing. But again, there's multiple different ways of skinning this cat. You can actually use node affinity and all that sort of stuff to target your pods into a particular node groups as well. But this is the simplest way of doing it. But there's other ways of doing it in Kubernetes. I've also included a little PowerShell script which actually initializes all these passwords and secret files for you, because when you're doing a POC, it'd be very useful, very handy. It's available in GitHub as well. Now, jumping back into AWS console, so your actual EKS cluster would be under AWS EKS. So if you click on clusters, you will see your clusters. So you can see this is my cluster. That's the version of Kubernetes it's running. There's a new version, 1.18 is the latest version that AWS EKS actually supports. And they go through this cycle of moving that. If a new version comes out, they move it into preview, and then once it's properly posted, it comes out as general availability. So I've used a older version like 1.17. So click through, and then so these are all my nodes and the sizes of the nodes. And if you click on the workloads, so that's where you will see all the pods that are deployed. And you can basically click through them as well to see what containers are. So you can actually have a pod with multiple containers as well. So if you click through, you will see what that pod is actually running as well. And if you want to look at, so if you go to EC2, you will see all the nodes that are attached to the cluster. So you'll see that naming is going after the node group name that I've actually chosen. Again, and if you click through an instance, you get through all the security, networking, and all of that sort of stuff. And the other thing is CloudWatch. So you will see that on top of the out-of-the-box Sitecore YAML files, there's a folder for CloudWatch. So this will allow you to sort of, deploy CloudWatch into your cluster. So what that does is it basically collects all your logs from your cluster, all the performance metrics and CPU usage and all that sort of stuff. So that's, that's CloudWatch. You can create your own dashboards. I just have a simple dashboard that I have, which shows you all the CPU utilization, memory utilization. Obviously, you can customize this. This is just a sample. And your logs will be in log groups. And so these are all the cluster logs. Yeah, so, and then performance monitoring. Again, I've added this to the dashboard, but yeah, then you have your resources. If you want to look at your individual resource and the CPU usage and the memory usage, yeah, you get that view from here. Now, so the other thing, yeah, so what I've done is basically I've spun up the cluster. I registered that IP address on my host names. So that's the IP address where this is running, and that's my, yeah, I've created all of those. So yeah, this is actually now running in AWS EKS. Does anybody have any questions that, or anyone want to see anything in particular on the AWS side?
I have a question.
Yeah.
So the delivery node group, right? In Kubernetes, you can actually define the resource utilization or resource limit as well. Once you get an idea of the depends on the cycle role that you're running, right? Sitecore content delivery role, you might specify it to have a minimum of 3 cores or 4 cores and 10 gigabytes, right? And then you would define whether you want to horizontally scale the pods up. Now, what is the benefit of having a dedicated delivery node group versus one node group where you define the horizontal pod auto-scaling and node auto-scaling if you have that rule in place?
Yeah, look, the only reason why I segregated them into a separate node group is sometimes you have a rogue pod, you have a pod that is actually misbehaving. For example, last week we had an instance where one of our clients, which runs on Azure Web App, right? And it's set up to auto scale. And when it auto scaled, one of the instances, for some reason, it just couldn't connect to SQL. It was just misbehaving. And we had 4 instances, but only one of the instances was not working. So sometimes having that instance could actually impact. So the performance, so that instance was actually consuming 80%, 90% CPU and memory, you see that peak and then, but when you look at Kubernetes, right? So if one of these pods is actually misbehaving and it's taking up all your memory in that node group, it's draining. So all the other pods in that node group would be affected as well, right? So because, they're competing for resources. So that's the only benefit of segregating them in a separate node group. But if you're confident of managing that with just policies, yeah, you can easily do that as well.
Gotcha.
Hope that answered your question.
Yeah.
Okay.
Oh, sorry. I was just adding another quick question, if that's all right. I was just wondering, we're having a bit of everyone's migrating to Kubernetes, and we've been talking about internally about what to do with Solar. Have you given, obviously for non-production workloads, you just spin up a pod that's running Solar and be done with it. But for production workloads, have you given that any thoughts? bringing in like something like search stacks, or looking at like running Solar yourself in like in a production type environment?
Yeah, absolutely. So we've done both. So like, previously we've had some of these Ubuntu VMs, like, spun up in Azure running Solar, but then you'd have to look after them. But especially after search stacks actually came out with like, the SaaS offering, we've been, all the new work that we've been doing is with search stacks. And some of the existing clients, we've actually migrated them over to search stacks because we don't want that extra burden of like, maintaining those Solar instances. It's someone else's problem. And, so search stacks has been like our go-to provider for Solar recently. And they're really great. They've got a lot of these automation stuff, and like you can use their APIs to spin up, and they're really good.
Now, I wonder if you can get search stacks. No, you wouldn't be. Do you reckon? Would they be able to like deploy into? You probably don't want them to deploy into your cluster, though, do you?
No.
Yeah.
So what in AWS landscape? So what they do is they do VPC peering. So they actually deploy Solar into a VPC, and then they do a VPC peering with your VPC. So then, like, it's still protected, but it's behind a VPC, and it's peered into your VPC where the cluster is running. And they do the same with Azure as well. So they actually deploy Solar in a VNet, and if you're running AKS, like, they do VNet peering as well.
Yep.
All right. So some of these, really good tips. So like, secret files, where all the passwords are. If you have line endings, you get into a bit of a pickle. I'm guilty of doing that. When I was actually automating the generation of these passwords, I was using PowerShell to set the content, and it added line endings, and I didn't realize it. And then I was banging my head, and Rob Erlin came to my rescue. I was like, hey, why is this new line at the end? I was like, oh, let me remove it. And then it just bloody worked. Just be careful of that. SQL passwords, the image that comes with out of the box, like Sitecore SQL image, complex passwords are enabled by default. So when you run the initialization job, it goes and finishes it, but it doesn't set the user permissions and stuff like that properly. And then when your nodes come online, they talk to SQL and they go, I can't talk to SQL. And I've ran into both the problems. Just make sure once you're, if you're using, like, if you're testing SQL out, make sure SQL init is successful. Some of the node selectors for init jobs, so the SQL init and Solar init, and these two jobs didn't have node selectors. So when I tried to run them and deploy them, it tried to sort of deploy them onto Linux nodes and then go, I give up. Sometimes it goes like onto Windows nodes and successfully, 1 in 5 times it'll probably end up on the right nodes, but most of the times for me, it ended up on Linux nodes and ended up failing. And then I had to add those node selectors to target that particular operating system. So, it only deploys on the Windows nodes because, that's where it's compatible. And especially in EKS, I'm pretty sure, like, in AKS as well, it's probably the same. So you need to have enough IP addresses available for your pods. So when you're deploying these pods into nodes, they need to have like an internal IP address for them to talk to each other, right? So you need to have those enough IP addresses available for the pods. With AWS, though, you can actually, when you're spinning up that node, you can actually have additional network interfaces. So instead of just having one network interface, you can have up to 3 network interfaces. So what that means is you'll have 3 times of the IP addresses that are available that can be allocated to the pods. I've included these couple of links that are really, really useful if you're actually deploying your workloads into AWS. Yeah, it's definitely worth a read. Yeah, so for the resources, I've used all the configuration files, the scripts, they're available on my GitHub. That's the link. I recently wrote a blog on how to deploy Sitecore on AWS Kubernetes. That's available on my blog as well. And some of the other really useful AWS resources, how to create Windows nodes, like how to work with Helm and push Nginx and stuff like that. I want to really show you this really cool tool that I've been using. It's amazing. Like it's really, really good. So this tool called Lens. So when you do a cluster, when you spin up your cluster, when you're executing your kube control commands, you need the kube config. So that lives in your profile. And now what this Lens app does is it uses that kube config, and then it will bring out the cluster. You can look at your nodes, you can edit them, you can run PowerShell scripts on the node, not just the nodes. Then you go into pods, you can see all the pods that are running in your cluster. There's more to it. So you can actually look at, say, for example, like, I have CEM. You can look at the logs directly from this app, so you don't have to run kube control commands. You can edit them as well. So for example, this is CD. So if you click on edit, it'll open up the actual YAML file. So if you edit this and save it, it's saved. Like it applies that change immediately. Everything throughout this window. So yeah, you can look at the deployments, the networks, the endpoints, ingresses. So this is my the Nginx ingress controller that's running. And you can look at this endpoint. So for example, this guy here. So that's my Nginx ingress controller, and that's where the external IP is. Yeah, like it's really, really handy tool. Not just Kubernetes, but like if you're using Helm, you can actually search for Helm charts. For example, you can actually just go find Nginx. So yeah, it'll give you the details of that chart and all the parameters that are available. I totally recommend this tool. I'm totally loving this tool, Lens. Again, like you can also use Visual Studio Code extension for Kubernetes. That does a job as well. But yeah, this is really good. Yeah, and that's kind of the end of the presentation. Does anybody have any further questions?
I have another question, but if someone has a question first, by all means.
Go for it, Aaron.
Yep. So back with the Lens. I've not heard of it before. So two quick questions. First is, can you uninstall Helm packages? Because I've got a cluster that I run myself, and I've been trying to work out a way to get rid of uninstall Helm package, what the best way
Oh yeah,
is.
That's really easy to do it.
Yep.
So I have a command. So like in my README, you will find, for example, all you got to do is just Helm
Okay. Yep.
install. You just pass in the deployment name, and then that does it.
Okay. I think my problem is I've forgotten all that. Anyway, that's all right.
Oh, you can just go like kube control, get deployments. Yeah. It'll list out your deployment names.
Does it say which ones have been installed by Helm though? because the problem is I've got a mix of both.
Ah, right, yeah. Actually, in Lens, you can probably see that, I think.
I think it's called release on Helm.
Where is that? Charts. Yeah. So if you use Lens, you go into releases, it'll tell you all the ones that were deployed using Helm.
Awesome.
And you can just click on this guy and remove.
Awesome. I was going to say, because my next question was like, what benefit does this have over like using Kubernetes, like the dashboard? But I think that's pretty much, other than being able to do stuff with Helm, is there any other advantages other than, because I might, like, this is not a Sitecore installation, this is deployed on DigitalOcean for just my own personal workloads.
Yeah.
That just comes out of the box with the Kubernetes dashboard. Is there any other advantage that you would know that you from using this that you would see over just using the Kubernetes dashboard?
Yeah, look, some of those dashboards, like for example, like there's another app called Portainer.
Yep.
For Portainer to work, you have to deploy a pod into your cluster. So it actually runs as an agent in the cluster, and then it takes commands from outside. But this Lens app is basically standalone. Like it doesn't need to do anything inside of the cluster. All it needs is access to your kube config, and that's it.
Yep.
It uses, it basically converts the UI stuff into a command. So like, when you're running any commands, you actually basically, it's running like raw commands behind the scenes.
That's cool. I might give that a play with tonight.
If anyone is interested in seeing, like, I wanted to show how, like, EKS actually recovers. So for example, like, I go into these EC2 instances. So I go, yeah, for example, like, I have this management node, and that guy, yeah. So I'm just like, basically simulating a real world problem. So like, you click on terminate. So what happens is now if you go into your pods, see this, that's running on management. So slowly some of these would actually change them into error. But what EKS does is, like, once it's died, it basically spins up another instance automatically. So in a few minutes, you should see another instance running. Hope the demo gods bless me. But in a real world scenario, what you would do is basically have, if you have, like for example, like content delivery, where you don't want to have your website down at all, then what you'd have is two instances, so two nodes in a node group. So like, they act as fail-safe. So if one node goes down, one of the nodes is still there to actually serve traffic. The other important thing is to make sure that those two nodes are actually in different AZs. So AWS has 3 different AZs, right? So you'd make sure that you deploy at least each node in a different AZ. So if one of those zones, for whatever reason, has like gone down, then at least the other zone can actually pick up. But when that zone goes down, what it does is, like, it'll try and spin up that other EC2 instance in another availability zone automatically.
Hey, Praveen, are you doing a blue-green deployment?
That is on my cards. I have a way of doing a blue-green deployments. It's in my pipeline for the blogs.
Yeah, cool.
But yes, I'm that's definitely on the cards. Yeah. So you can see that this other instance is now spun up and it's initializing basically. So once it goes through initializing, and then you'll come back into, so see these pods, they're actually pending. So basically, as soon as that node is ready, these guys would go and like get deployed on that. But yeah, so like, I just wanted to demonstrate what happens when a like EC2 instance goes dead. It recovers automatically. So that's the self-healing capabilities of EKS or like Kubernetes environments. Yeah, so I think that's pretty much what I wanted to present. Thanks, Gary, for coming along and giving us your insights on AWS and the containers and EKS, and it was great.
Thanks, Praveen. Thanks for giving me the opportunity. Really good to come here and talk to you guys about what you can do with EKS.
All right. I think if no one has any further questions, I think that's pretty much it. Jen, over to you.
Thanks, Praveen. Thanks, guys. Really appreciate it. Any final questions? Anyone would like to say anything? Add anything? All of this, the recordings and the slides will be available at the Meetup page and the YouTube channel. So feel free to check out and ask any questions there. Thanks, guys.
Yes, everyone.
Thank you so much.
Everyone.